So now let's take a look at how we solve limits analytically. So I just give you a function and we're just going to compute the limit sort of directly. Now, here's kind of the steps that I tend to follow. So first step, I'm just going to plug in the value of x into the function. If I get a number, usually fine. That's your limit. If I get 0 over 0, I have to do some kind of manipulation to cancel out some terms. So I have to do some algebra. We call it 0 over 0 kind of an indeterminate form. And if I get a non-zero number divided by 0, then it's some kind of infinity, and I have to do some one-sided analysis to decide whether it's positive or negative infinity. So that's kind of like the general rule of thumb. But we're going to just go through and some problems and do like this. So compute the following limits. As x approaches 1, x squared plus 3. I'm just going to plug in first. And if you get a number, then you're usually good, right? So this is 4 minus 1. That's negative 1 there. Okay, here I'm going to plug in negative 1. This one is easier. If you see a fractional one, it's usually easier to just kind of factor first anyway. I think that's what it factors into. Notice if I plug in negative 1, I'm going to get 0 over 0 here, okay? Which is indeterminate. But the thing about this one is if you cancel the x plus 1s and then you plug in negative 1, then you're not going to have a problem. So that's 6 over 4 or 3 over 2. Okay, similar thing, I can, if I plug in 3, I'm going to get 0 over 0. I'm going to get 9 minus 9 over 3 minus 3. That's 0 over 0. So what I have to do is do some manipulation, factor this, cancel the x minus 3s, and then I can plug in 3. So 3 plus 3 is 6. Okay, this one is the limit as x approaches 2 from the left. So the tricky thing about this one here is the absolute value. Like, you do want to factor the top and factor the bottom. The problem is this absolute value. It's almost like I want to get rid of it. Now, here's the thing about absolute value. Absolute value does one of two things. If the inside the absolute value is positive, you do nothing. If the inside the absolute value is negative, you multiply by negative 1. Let me give you an example. If I do absolute value of 3, nothing happens. If I do absolute value of negative 3, it's like I did negative 1 times negative 3 to give you positive 3. Okay? So in this case, you have to decide inside this absolute value, is it a negative number or is it a positive number? Well, if you're approaching 2 from the left, this quantity will be negative. Right? So then you can say that this is x plus 2, x minus 2 divided by negative x minus 2. And then what happens is the x minus 2's cancel, and then I can plug in 2, and I would get 4 over negative 1, which is negative 4. All right? Let me go on a little bit more. Okay, how about this one? 2 from the right, right? X approaches 2 from the right. Now, when you're doing this, when you're doing the x plus 2, x minus 2, it's just factoring. Now, because you're approaching 2 from the right, the inside the absolute value is already positive because you're approaching 2 from the right side. Number's bigger than 2. So number's bigger than 2 minus 2 is positive. So I can just drop the absolute value sign. And then these cancel. And then I can just plug in 2 and I get positive 4. So look at this one. From the left and the right, I get 2 different limits for this function here. Okay, what if I have some square roots? Limit as x approaches 1. I plug in 1 here. 1 minus 1 is 0 over 0. It's going to be 0 over 0, right? So I have to do some algebra. But I can't just factor or cancel because it's square root. But I can multiply by the conjugate. This is what I want to do. And why do I do that? Is because when I FOIL this guy out, it's going to become x minus 1 because it's going to be root x times root x, which is x, and then minus 1 times plus 1 is minus 1. So you're going to get x minus 1 over x minus 1, then root x plus 1, like that. And then these guys cancel. And then I can plug in 1, and I get 1 over 2. Because if I plug in a 1, square root of 1 is 1, plus 1 is 2, so 1 over 2. How about this one? I'm going to plug in 2. I'm going to get 4 plus 5 is 9. Root 9 is 3. 3 minus 3 is 0. This would be 0 over 0. So again, I have to do the trick where I'm going to do square root x squared plus 5 plus 3 over root x squared plus 5 plus 3. And convince yourself to FOIL it out, right? FOIL out number 7 and convince yourself that what you're going to get is that times that, which is just x squared plus 5, because the radicals are squared because you're squaring it. Then the outer and the inner terms will cancel. That's why we use the plus sign, and you're going to get minus 9 over x minus 2 times root x squared plus 5 plus 3. Okay. This becomes x squared minus 4, which I can factor into x plus 2, x minus 2. Oops. And this is what you're always hoping for. You're always hoping to cancel that x minus 2 so that now you're not going to get 0 over 0 when you plug in. So you're going to get 4 on the top, and then 3 plus 3 is 6 on the bottom. So this is 2/3. Let's look at number 8. When you have a fraction, a couple ways to do this. Again, when you plug in 0, I'm going to, that's a plus sign. So it's going to be 1 plus, plus negative 1, which is 0 over 0. So you can have 0 over 0. Now, there's a couple ways to do this. You can combine this fraction, or you can clear out the fractions by multiplying the top and bottom by x minus 1. This is probably the cleanest way, but you could also do common denominators and add the two fractions, okay? So when I do x plus 1, x minus 1 times that, the x plus 1's cancel. I'm going to get x minus 1. And then when I do this times this, the x minus 1's will cancel, and I'm left with x plus 1 over x times x plus 1, x minus 1. Because I have to multiply the top and the bottom by the same value, right? So then the top just becomes 2x, and then your x's will cancel. And then I can plug in 0. So it's going to be 2 over, x plus 1, x minus 1. That's 1 times negative 1 is negative 1. So that's 2 over negative 1, which is negative 2. How about this one? I'm going to get 0 over 0 again. But again, the trick is the denominator is the guy that I have to do the conjugate from. Okay. So then I'm going to get x times 3 plus root x plus 9. And then the bottom will become 9 minus x plus 9, which is just negative. So then the 9 minus 9 will cancel. I get negative x. That will cancel with that. And then I can plug in 0. So it's going to be 3 plus root 9 over negative 1. And then that's just negative 6. Okay. Now here's an instance where when I do 1 over x, when x approaches 0, 1 over 0 is undefined, right? And it's some kind of infinity, because you have to remember, I'm not really dividing by 0. I'm dividing a number close to 0. So to analyze something like this, you want to look from the left and the right first. It's some kind of infinity, but you have to decide if it's a positive infinity or negative infinity. If I approach 0 from the left, it's a tiny negative number. It's like negative 0.01. And so 1 divided by a tiny negative number is going to be negative infinity. Whereas from the right, I'm going to do 1 over a tiny positive number, and that's going to be a giant number, or positive infinity. So because they mismatch from the left and the right, we say this does not exist. So when you have like the 1 over zeros, you kind of want to like look from the left and the right. This one's going to kind of have the same thing happening to it, because you're going to do 1 over a tiny number, so some kind of infinity. So from the left, well, it's a negative number, but when I square it becomes positive. So 1 over a tiny positive number is positive infinity. And then same from the right. 1 over a tiny positive number, still positive infinity. So therefore, this is infinity here. Okay. How about x approaching pi over 4? Remember the first thing, I'm just going to plug in pi over 4. So that's cosine pi over 4. Sine pi over 4. It's root 2 over 2 times root 2 over 2, which is 1/2. It's 2 over 4, or 1/2. How about 0 from the right for ln of x? This one you kind of have to know what natural log looks like. Natural log looks like this. So remember, it's a vertical asymptote at 0. So if you're approaching 0 from the right, this is going to be negative infinity. That's what natural log tends to do. Okay. What if you have ones that are like a difference, right? 1 over x minus 1 minus this. So I plug it in, it's going to be like 1 over 0 minus 2 over 0. Well, you want to make it a single fraction. So one of the things you could do is multiply the left one, because this is going to be x plus 1, x minus 1. You could do, let me write it like this. To combine the fractions, I want to do common denominator. I'm going to multiply this by x plus 1 over x plus 1. And that's because then they'll have the same denominator, and then I can combine the fractions. Over x plus 1, x minus 1. Which the top just becomes x minus 1, right? Plus 1 minus 2 is x minus 1. Then the x minus 1's cancel. And then now that I've done that, now I can plug in 1. It's going to be 1 over 1 plus 1, which is 2. Okay. How about this one? This is the same with the absolute value, right? You're going to factor the top. Right? And then you want to say, well, I'm approaching 2 from the left. Right? So this is going to be, this absolute value is a negative, like the inside is a negative number. So you can strip the absolute value away, but you have to put a negative sign in front because you have to flip the sign. Now negative x minus 2 would be a positive quantity, right? And then one of those x minus 2's will cancel. And then I can plug in 2 and I get 0 over negative 1, which is just 0. Thanks for checking out this video. I hope you found it really helpful. If you'd like more support, maybe you need more multiple choice practice, maybe you just need more guidance and things like that, I have plenty of information on my website. If you look in the description below and go to www.bothellstemcoach.com, I will explain all the ways I help students be successful in their AP classes.